is Zhenlan Hu, and I will be presenting my midterm report presentation. The title of my presentation is about understanding the fundamentals of system engineering through the case study of SpaceX's innovative Falcon 9 rocket. Before moving on to the presentation, I'd like to briefly introduce the trend of system engineering. System engineering is a long-existed and well-developed engineering discipline. However, it is also a developing forefront, means that given the technology advance, the engineers and scholars are reshaping this area of system engineering. A formal definition of the concept development stage is the following. It embodies analysis and planning that is necessary to establish the need for a new system, the feasibility of its realization, and the specific system architecture perceived to best satisfy the user needs. Given the definition, two important keywords. First is there must be a need for such a system. And second, the feasibility. The new system cannot be just a wild guess. It has to be physical, in other words, economical for realization. A brief history about the SpaceX company. SpaceX company was founded in 2002 by Mr. Elon Musk. And the goal of the foundation of this company is to build reusable rockets for spacecraft mission and mission in deep space. And a further goal is to enable humans to colonize other planets, including Mars. The most recent progress about SpaceX is SpaceX self-developed spacecraft, Crew Dragon, recently docked with International Space Station a few days ago. And this marked the first ever privately made spacecraft that docked with ISS. SpaceX is also a pioneer in private commercial rocket development and manufacturing. So far, the most advanced Falcon 9 series rocket is the most powerful rocket ever made by human. And this picture gives a general idea about the Falcon rocket family. On the far left side of the picture, it's a Falcon 1 rocket. As we can see, the size, the model is quite small. And as moving on to the Falcon 9, the size gets stable and get much larger. It's a two-stage rocket. The payload is on the top of the rocket and the two-stage, and then the Merlin engines are installed at the bottom. There is also another type called Falcon Heavy. The Falcon Heavy rocket is basically for lifting heavy load payload and spacecraft. Moving on to the first stage, the concept development stage has two subparts. First is to do a need analysis. Going back to the definition, we have to make sure there is a valid need for a systematic technological development. And second, there must be a practical approach existing to satisfy such a need. To further elaborate need analysis, we are focusing on the following points. So first is the rocket usability. In the past, the rocket is a one-time use equipment. Whenever we launch a rocket, the rocket basically becomes wasted and were discarded into space as a debris. And this is very costly because whenever we launch a rocket, the rocket itself is sunk cost, and we have no way to spread out the cost to make it a variable cost. So SpaceX need analysis focus on this type of issue. SpaceX wants to make rocket reusable, so multiple use. So therefore, we can spread out the the manufacturing and development cost to make it a variable cost rather than a sum cost. The second is SpaceX is trying to increase the safety and reliability of the rocket. There is a need for a safer and more reliable rocket to continue with other complicated space missions. The third, the society and the technical field really requires a new manufacturing or management technique, if you will. The commercialization or privatization of rocket manufacturing. In the past, the rocket manufacturing and development was solely controlled by state-controlled agencies like NASA. However, it is inefficient and it's quite costly for a state-controlled government agency to manipulate or to schedule all these manufacturing stages. We want to find out a new way that there's a need for commercialization or privatization of rocket manufacturing. And there exists a practical approach for SpaceX. SpaceX already constructed a lot of infrastructure for testing and integration purposes. And just for example, that SpaceX has a very large testing facility called Propulsion and Structure Test Facility in Central Texas. It occupies over 1 square mile, 2.5 square kilometers, and it is state-of-the-art testing and integration facility. And second, reusability. There are practical approach to make reusability a reality, such as we can install grid fins onto the body of the rocket. We can implement gas thrusters to maneuver the rocket before landing smoothly on the surface. And scientists and engineers also redo the fuel calculation. In the past, the fuel was only enough to send a rocket to the Earth's orbit. Now we need to recalculate the fuel to have enough fuel to send the rocket back onto Earth. And this has been a proven approach. It is workable, it is practical due to the recent success and accomplishments by SpaceX. Moving on to the second phase, the concept exploration phase. The new system should be able to perform certain desired function outlined by system engineers, business analysts, and corporate executives. And there is at least one feasible approach to achieving such performance at affordable cost. So what function should be performed with such a new system? So the first function is we need to make sure that the Falcon 9 rocket is able to send or lift large payload weight into Earth's orbit. As humans begin to get started with more sophisticated space mission, we are going to transport heavy equipment and more personnel into space. So the rocket must be able to handle such large payload weight. And second is reusability, and goes back to what we were just talking about. We need to make sure that this Falcon 9 rocket is able to re-enter the Earth's atmosphere after completing its lifting mission. And engine's power. This is a bit tricky. The Falcon 9's Merlin 1D engine has to be powerful enough to lift the large payload in the first point. However, the engine has to also to be delicate enough to handle. Must be delicate enough to handle a sudden maneuver just before landing on the designated area. So the engine's power is a twofold thing. It has to be powerful enough, but also needs to be very delicate, to handle emergencies. And engine out capability is a similar concept that whenever one of the engines goes out of power, the other engines must be able to compensate for the loss of power. safety for sure. We need to find a way to increase the safety to make the rocket more reliable. The rocket is a two-stage rocket, and each stage has several engines. And another function that Falcon 9 has to be able to provide is navigation and the software package support system. The flight computers, inertia, navigation system software are primarily used for the flight, the navigation, and the last stage, the precision landing. And my report, based on the research, can show that there is at least one feasible approach to achieve such performance at an affordable cost. So the first thing that engineers can do to Falcon 9 rocket is to add the restartable ignition system. The restart ignition system is basically installed to put the booster on a descent trajectory, so the booster, the rocket, can re-enter the Earth's atmosphere and get back onto Earth. Second, altitude control technology. So altitude control technology essentially brings the descending rocket body through the atmosphere in a manner that's both non-destructive and also satisfies sufficient aerodynamic control so the terminal phase of the landing is possible. The third is hypersonic grid fins. So hypersonic grid fins should also be installed in order to return precision landing into a reality. So grid fins are usually arranged in an X configuration, and they are used to control the descending rocket's lift vector once the vehicle returns to the atmosphere, so we can enable a much more precise landing. Fourth, the Merlin 1D engine. The Merlin 1D engine not only are used to provide power to lift the rocket, but also to reduce the engine thrust. And software support. As we mentioned before, the software support and software packages are used for navigation and are also used for precision landing. They must be able to provide sophisticated algorithm to help the navigation system to find out the precise landing point and also to calculate the appropriate trajectory back onto the Earth. The last but not the least, the thermal protection system. The thermal protection system is used to absorb the heat load when the rocket re-enters the atmosphere. And moving on to the third phase, the concept definition phase. There are four subcomponents: relative performance, operational utility, development risk, and cost. So, the first, the relative performance. In the past, as we mentioned before, the elder generation rocket were only a one-time use animal. It's not equipped to do multiple missions. But now, what we are trying to design, or what the SpaceX is trying to design, is Falcon 9 rocket that's able to perform multiple missions without discarding the rocket itself. So the rocket must be able to be reusable or recyclable. And another relative performance compared to other alternative or the elder generation is reliability. So the Falcon 9 rocket is more reliable, is safer, due to the reason that the rocket is installed with more sophisticated Merlin 1D engine, and due to the new altitude control technology, and also due to the reason that it installed the altitude control safety mechanism that can do quick maneuver just before landing on the surface. Operational utility. So this new type of next generation rocket is very useful from an operational perspective, is because first, it can send a larger payload into space to fulfill other space exploration mission. And second, it's useful because it goes back to the last point that it can significantly reduce the launch cost. However, there is also many development risks. One of the most important risks is that this is a brand new technology that it's different from the prior type, the elder generation rockets. So there's not too much experience to borrow from the elder generation rockets. And going to the last point is the cost. From the official website of SpaceX, we can see from this table, if Falcon 9 become more mature, the technology become more stable, it is estimated that one single launch of Falcon 9 rocket cost about $62 million. And launching a Falcon Heavy rocket cost roughly about $19 million. And this number is a significantly reduction from launching the elder generation rocket, which cost significantly more. And another number that's not shown here is that the total research cost to develop Falcon 9 and Falcon 9 rocket is roughly $300 to $400 million. And a verifiable source has told that if it's allowed if the NASA were to develop such a similar Falcon 9 booster rocket, it's probably going to take $4 billion rather than $400 million. So if we allow NASA to develop such a system, it's going to be 10 times more expensive. So we can see the cost is economical, is feasible, and Falcon 9 series rocket significantly reduced the launch cost due to its reusability feature. And this is my presentation. Thank you.